This is the first one, and then the others are below.
Yes.
Now, what are we saying in this one? For what values of x?
Before class
Okay. All right. For what values of x is f of x, which is equals to x plus 1 over x minus 5 continuous? Anyone?
So now what I can show is that x is not supposed to be 5.
X is not supposed to be 5.
Yes.
Yes, we agree, yeah? Now, we agree on this one. Anyone who disagrees? This was our homework.
No, we agree.
Agreed. Very much agreed.
Okay, if we agree, now we are going to exercise set 1.6e.1.
Yes.
Here we are. It was only the first 4 questions. Then we agreed that even those that we've already revealed their answers, my request was that you go, you work through them. If you've got different answers, then we can start to talk. That was the agreement, yeah? Remember, I asked you to take pictures of questions 1 to 4. Theo, that was the agreement, yeah?
Yes, it was, sir.
And then I did mention that even though there are those answers for question 1 and 3, please go and work on them. And then you and I will take our engagement further if you are getting different answers from those that they got in number 1 and number 3. In number 1. Okay, Abdul, you say you are not here. Okay. Lerato, you were here. Theo, you were here. Who else was here?
Tando.
Tando was also here. Okay, now, Tando, do you agree with the answer in number 1, for number 1?
Yes, and I said therefore the function of x is discontinuous at x is equal to 5. I think it's the same, yes.
Number 1. Can you see my screen now?
Oh, not the homework. Okay, so yes, yeah, this one I got the same answer.
This is part of the homework, Tando. That was our first question. Tando, are you still with me?
Sorry, say I unmuted. I didn't see it. I thought I'm still unmuted.
No,
Okay.
Tando. What I'm saying is that what you are talking about was the first question to our homework.
Okay, this one, function of x is equal to 1 over root of x.
Yes, now it's a continuation of our homework. Do we agree?
Yes, I agree.
Now my question is, do you agree with this answer in number 1?
Yes, I agree.
Theo, Lerado, do you agree?
See, I don't know how they got the answer.
You don't know?
How they got the answer. There.
Okay. Theo?
So I would also like clarification on that as well. I'm a bit confused with it as well, for number 1 especially.
Tando, can you help?
No, say I can't help. on this
Sir.
on this topic. I just
Sir.
put 0 there, then I saw that it's infinity or whatever. Then I agreed with it, but I don't know how I did it. So
Yes, thank you, Tando. Someone was calling me.
It's me. On this topic here, we must find f of a. I agree with the answer, but on my working, I cannot find f of a, which means I cannot do those rules, the 3 rules you gave us, for us to prove where the graph is, I don't know, continuous or what, like because it's a fraction. Yeah.
So not to come in, what I can say is, judging from what I'm seeing, we know that anything that could be under the square root is not supposed to be negative. And it can't be 0 because we can't have our denominator as 0. So judging from that interval, which is given 0 to infinity, it means this function will always be continuous except when x is 0. We don't talk about negatives because it can't go into the negative direction. We can't have a negative square root. But based on what I'm seeing, they are saying it's continuous based on the mere fact that if you are to plug in any value that is greater than 0, it will always have a point to it.
Oh, wow. Thanks.
Please repeat that, Abdul.
I'm saying, looking at the function, we have a square root at the bottom of the denominator, on our denominator. And we know, mathematically speaking, we can't have a negative square root. So you can also plug in 0, looking at the fact that it will make it undefined. So you'll have to start counting numbers that will be greater than 0. So if we have square root of 1, for example, it will be 1 over 1, which is defined. And every number moving up from 1 all the way to infinity, it will always give you an answer which makes it continuous in that particular sense. So this is continuous, and yeah, we are being given that interval from 0 to infinity. 0 is not included, but from 0 to infinity.
0 and infinity are excluded in this case.
Yes, they're excluded.
Thank you for the explanation. Anybody who doesn't follow Abdul's explanation?
Sir, I follow the explanation. So in this case, we don't need to find limits and what.
We don't need to find what limits.
No, to find f of a, and then we prove via f of a if the graph is continuous or not. Like that, the top say, classify the or if it's discontinuous. Okay, now I understand.
Now, yeah, Lerato. Now let's look at number 2. Lerato, what did you get in number 2?
I'm not sure.
Yes.
I said it has a jump 1, a jump infinity.
Why?
So the limit were not like from the left hand side to the right hand side, the limits were not equal.
So if we've got if the limits while approaching a point from the left and to a point from the left and a point from the right, where they are not equal, we are saying
jump. I think it's jump. Yeah, it's jump, sir.
Please ask them.
Guys, do you agree that if the limits from the left hand side are not equal to the limits to the right hand side, it's a jump discontinuity?
That one I agree with you on. In this case, we are focusing on this number 2 to say, what is the answer, Lerato?
Determine the point, if any, at which the function is discontinuous. The point is 2.
Now what I would say, sir, to come in, I think this one is also continuous for whatever value, because there's no value that we can substitute for x squared, which could make our denominator 0. So even if we were to plug in -1 in that x squared, it would still make it positive. So I would say this one is continuous for all values.
Can I jump in?
Yes, please.
But if sorry about that. But if x squared, if x was -1, if we were to square that, wouldn't we then have a 1 + 1, which is equals to 0?
1 + 1 is 2.
1.
Oh, I see what you mean. Okay, never mind. Yes. Yeah, you're right. Okay. Yes, because 1 + 1 is going to be 2. Sorry. Yeah.
What is your conclusion, Abdul?
I'm going to say this one is continuous. I don't know if they agree with me or not.
Please talk to them.
Guys, do you agree if it's continuous or not?
Yes,
Yeah.
we agree.
Before, let me go. We are now on page 244. Let me go here, Abdul. Because what you are talking about is revolving around this 1, 2, and 3. Just to remind you, f has a removable discontinuity if the limit of f of x as x approaches a exists. Now, number 2, Abdul, then I will request you to revisit what you just said to us. Number 2, f has a jump discontinuity at a if the limit of f of x as x approaches a from the left and the limit of f of x as x approaches a from the right both exist but are not equal. And then f has an infinite discontinuity at a if the limit of f of x as x approaches a from the left as well as the limit of f of x as x approaches a from the right both equals to positive or negative infinity. Does a bell ring? Yes or no?
For me, it's
Yes
still a bit
or no?
confusing, especially when it comes to stating whether it's removable jump and whatnot.
I'm with Mr. Abdul there. That also confuses me too sometimes. A lot, actually.
Okay, this is what we are saying. In number 1, we've got a function.
Yes, sir.
If you've got a function, which is f, and then in that function, where the limit of that function exists when x approaches a, then we say that function has got a removable discontinuity.
So by saying that, so if it exists, meaning the limit from the left and the limit from the right will be the same.
No, you are now looking, what you just said is now referring to number 2, Abdul.
So if the limit exists, let's say for the left, and for the left you get 2, and then the limit exists for the right and you get 3. So it will now fall under your jump discontinuity because of the limits from the left and the right are not the same.
So they exist, but they're not the same.
Again.
My question is, let's say you do have the limit exists according to what the statement is saying, but the limit from the left is not equal to the limit from the right. So that will make it a jump discontinuity.
as x approaches a.
Yes.
That will make it to be a jump discontinuity. Yes, I agree with you.
Okay. And then if the limit exists and it's equal for both sides, meaning the left and the right are equal, then what is it going to fall under?
If the limit exists, that is what number 1 is saying. Okay, you and I, let's just not stop. Number 1 says f has a removable discontinuity at a if the limit of f of x as x approaches a exists, full stop. Okay.
Okay.
So
now
the question
let's yeah, I'll be with you, Abdul. Now let's focus on the bracket. The bracket says, note, when we state that the limit of f of x as x approaches a exists, we mean that the limit of f of x as x approaches a equals to L, where L is a real number, any real number.
So here we don't look at equality or from the left and the right, as long as
No.
the limit exists and it's a real number.
Yes.
Okay.
Is it making sense?
It's making sense now in
Yes,
terms of
it is.
differentiating the
Yes,
two.
it is.
Now, let's revisit number 3. Number 3 says, f has an infinite discontinuity at a if the limit of f of x as x approaches a from the left is positive or negative infinity, or the limit of f of x as x approaches a from the right is positive or negative infinity.
I think that one is straightforward, sir.
Oh, it finally makes sense.
Sorry?
It finally makes sense, sir. Thank you.
Finally makes sense. Now,
Yes,
can we
all
now
of them
go back
finally
to,
make sense.
can we now go back to those questions of ours?
Okay,
Yes.
before we move, sir, while we're still here, before we move, sir, can we see this example 1.66? Can you see that, sir?
I can see.
Yeah, so my question here is looking at the denominator. Yeah? As long as there could be a number that we could substitute into the denominator, which could make it 0, can that be used as a way to classify if a function is continuous or not continuous?
Here, Abdul, we are not talking about continuous or not being discontinuous. Here we are only focusing on discontinuity.
Okay.
All these 3 points are talking about the type of discontinuity.
Okay, sir.
There is no where they are referring to continuity.
Now, I was speaking in terms of, let's say, if you were to use that method to identify before you even go any further, before you start jumping into removable jump or infinity, you first have to discover if it is continuous, right? So my question would be, could we use the denominator in this sense? Because we have x minus 2 and we are told that it is discontinuous at x equals to 2. So even if, let's say, we were not told it's discontinuous at x equals 2, but can you look at the denominator and see if let's say we were to substitute 2 and we get 0 somehow, whatever it was, we get 0 at the denominator, can that be used as a way to classify or to find if a function is continuous or discontinuous before we even jump into the types of discontinuity?
Okay.
Yes.
I hear what you are saying, Abdul. Now, that is taking us back. Where were we?
Sir, can I
those
give
of you,
advice?
those of you who were here, do you still remember?
You spoke
Where
of
Abdul,
I think so. What you spoke of, Lerato mentioned something like f of a has to be defined, and then you have to check if the left and the right are equal. And then there was this third last step. So if it meets all those conditions, then it would be continuous.
Someone was talking. Is it Spusis or who?
Yes, I wanted to give advice, sir.
Yes,
Sure,
brother,
come in.
please.
Okay. When you have a rational function, when you have something on the numerator over the denominator, when the denominator is 0, it means you have an asymptote in the function,
Sure.
meaning your function is infinitely discontinuous when you have a 0 on the denominator. Yeah, when you have 0 over 0, you have a whole, which means it's a removable discontinuity. I hope that helps.
It does shine some light. Thanks.
Spusiso,
Yes,
do
sir.
you remember that in the past few workshops that what Abdul is talking about is in fact what we dealt with? Okay, since you are saying time is money, now let's go to our exercise, which is, okay. Now I'm stepping off this. I just needed to remind you about this. Let's quickly look at those questions for our homework. Here. Now, with those three in mind, with those three, what should I call them? Explanations in mind. Now, let's come here. 1, 2, 3, and 4. What are we saying here in number 1? We said, still going with Abdul's explanation?
I still
Yes,
stick
sir.
to it. I don't know what others.
So what I don't understand about Abdul's explanation, the answer there involves 0, and Abdul says we don't put in 0. So I agree with Abdul, we don't substitute 0, but why is there a 0 on that answer? Can you explain that part?
0 is not included, remember, because the bracket is round and it's not square.
Correct.
So it doesn't include 0. So it excludes 0 and infinity. And if we had square brackets, it was going to include 0 and infinity.
I agree.
Sir,
Yes, sir.
I don't know whether you agree with them or disagree with them.
So can you explain the 0? I understand the brackets thing, but I thought a circular bracket means that we are continuing and it's used for 0. Okay,
Yes.
so can you explain that part?
This curly brackets means also including. I agree with you.
Also including 0.
Also including. Okay, now let's talk you and I. If we put a 0 in the place of x in number 1, what will we have?
I think we'll have 0. So I think the square root of 0 is 0. So.
What is 1 over 0?
Undefined, sir.
What type of discontinuity will that be?
It's an infinite discontinuity, sir.
From those three?
Yes.
Remember, all these questions, our answer have to revolve around those three.
Yes, sir.
You say it will be an infinite discontinuity.
Yes.
Okay, let me keep quiet. Please talk to them about that one.
They won't talk because they say we are excluding 0.
No, like,
so I don't understand the part where we say, why do we exclude 0 when there's a 0 there? That's my question.
There's someone who came in and spoke about 1 over 0 being, what was it, removable, and then 0 over 0 being a whole. But to try and come in, Spusi, so you really can't have 0 because it's going to be undefined, and that 0 is like an asymptote. He said it's an asymptote. So it's a line that is there, and the graph will never touch that line, but will always be moving closer and closer to it. So you cannot have 0 because it's not gonna work. And according to the notation, those brackets, like I'm saying, you do not include. It's just the interval that was given to you, and within this interval, they are telling you what these numbers are between 0 and infinity. Do not include 0 and infinity. But whatever set of numbers you are looking for are between this range.
Mr. Abdul, isn't it our graph discontinuous at 0?
It is. That's where the asymptote is. One of the colleagues spoke
Okay,
about an
I
asymptote.
understand.
So,
Hello.
like on number 1, according to what I see, I believe it's the removable discontinuity, because it's like they removed the other part of the graph so that it can be only on this side. Like the negative part of the Cartesian plane was removed. So I don't know, like, and also what's this? When you find the limit of 1 over cube x, you get a real number. So I'm not sure.
Lerato, I'm confused. I want to understand you, but I'm confused.
Yes, I'm also confused. That's why so I'm saying, according to what
Now, how can two blind people show each other the way?
the light.
I want to understand you. If you are
Okay.
blind, I need to be able to show you the way. If you are blind, you need to be able to show me the way.
Okay. Question number 1. The limit of 1 over root x is a real number, which is half. And so
Sorry, the limit of 1 over
root x is half. So then from there, for removable discontinuity, the limit has to be a real number. That's why I chose removable discontinuity. I don't know about the others, because it's like on these questions, it does not matter what happens. You must find those limits and then use them to conclude whether is it removable, jump, or infinite. Yeah, that's all.
Magwena. Magwena,
Yes, sir.
help me, my sister.
Okay, I'll try. I'm not sure about the answer. I think our graph is infinite discontinuous at 0 and infinity, because Lerato, when you put 0 on under the when you put 0 on our graph, when you substitute 0 on our graph, you get undefined. So I think the undefined graphs are infinite discontinuous. I don't know if I don't know about I don't know if my answer is correct or not.
Sir,
No.
the issue here, it's not, I understand what they're saying, that if you put -2, negative root 2 will be undefined. If you put square root of 0, it will be 0. 1 over 0 is undefined. So x has to be from 0 to infinite. I understand that. But what I'm trying to say is this. According to the things you made us read, you said we should find limits. Unless I'm saying the limits that I found it's wrong. The limit to 1 over
the
x.
removable discontinuity should be the limit should be a real number. Like
And
we
I
should
found
find
that's why
what real number found.
half. So that's why I'm
Okay,
asking.
Lerato. Lerato.
Yes, I'm listening.
Do you see this question?
Question number
Do
1.
you see the words in bold above the question?
Yes, I see them.
It says determine the point or points, if any, at which each function is discontinuous.
Okay.
Any point or any points. Okay, let's say in number 1, if we put a 0 there, what kind of a discontinuity will this have? That will be number 3 amongst those 3 that we talked about.
Yes.
If you put, let's say, if you put 2, it will be number 1. Do we agree?
Yes, removable one. I agree. Okay, I understand now how you solve the question. So, see, that's why they said the function is defined for all x in the interval 0 to infinity. So it's okay, I understand. Yes, I understand it.
Now, when we come to number 2, what are we saying? Help me here. What are we saying in number 2?
Hello, sir.
Tando, yes.
Yeah, I agree with Abdul because when I read here, they said or other there at the end. They say determine the point, if any, at which each function is discontinuous. Classify any discontinuity as jump, removable, infinity, or other.
Mm-hmm.
So on this one, the way how Abdul explained, I think the answer will be function of x is equal to 2 over x squared plus 1 is continuous for all real values of x. It does not have any points of discontinuity.
Is continuous at all values of x except this 0 and infinity.
You said number 2, ne?
No. Hang on. Are we done with number 1? We are
I
saying.
believe we are.
Yeah, we are done with 1 because it has an answer. That's why we are.
Okay.
Yes.
Are you now talking about number 2, Tando?
Yes. We said
Okay.
number 2.
Okay, please talk about number 2. I'm listening.
Okay, I was saying I had Abdul explaining, then it made sense to me. Then I came up with the conclusion that function of x is equal to 2 over x squared plus 1 is continuous for all real values of x. It does not have any points of discontinuity. So I used that or other there. I didn't say jump, removable, or infinite because they said or other. So it doesn't have any discontinuity. This one does not have any points of discontinuity.
Because if you put any number
Yes.
there, you will still have a number, any other number.
Yes.
There I agree with you. Now let's look at number 3. Anyone who disagrees with number 3?
Oh, sir, question.
Yes.
So this graph is discontinuous at 0 and also at 1. Okay, so
Where are you? Are you on number 3?
yes, number 3.
Uh-huh.
So like on my case, I said it's discontinuous at 0, and that one I don't get how it is infinitely discontinuous at 1.
This is what they are saying. If you place 1 where there is x, either in the numerator or denominator, what will you end up with?
1 over.
Let's say you are putting 1 wherever you see x. What will you have?
1 over
0.
1 over 0. I understand now.
Okay. Thank you. Now let's look at number 4.
We are
Hello?
moving. Can you
We are
confirm?
moving,
Because there's a colleague who came. So when it's 0 over 0, it is a removable discontinuity. Whenever we have that form, 0 over 0, it's removable. And then when it's 1 over 0, it's infinite.
Hang on, Abdul. Please repeat, Abdul.
So if we have our fraction in this case as being 0 over 0, because let's say we're to substitute 0 into number 3, we will have 0 over 0. And according to the answer there, it says it's a removable discontinuity at 0. So if we have our fraction taking a form of 0 over 0, it's safe to assume that it will be a removable discontinuity.
Because it's 0 over 0. That is a number.
Oh yes, correct. And then 1 over 0 infinite. All right, hi, sorted. Thank you, sir. You can continue.
Okay. Now let's look at number 4. The last one was number 4. 1 over t plus 1. What are we saying in there?
Infinite, sir.
Infinite.
Yes, sir.
Discontinuity.
I'll go with infinite
Yes.
as well, because we'll have a 1 over 0.
1 over 0. What about that plus 1?
Because there's no t variable to it, we can let it go. It's like finding the derivative of a constant, which is 0. So is it safe to just not pay much attention to it because there's no t variable to it?
So in this case, we don't mind 1 because we can't say 1 over 0 plus 1. 1 doesn't count because we already have 1 over 0, which is undefined. So you can't add 1 to something that's undefined, sir.
He said, talk to us, don't keep quiet. Say you're stressing us.
No, I'm
He's
listening.
taking his time.
So come back with your explanation. What are you saying?
I'm saying my reason for saying it's infinitely discontinuous at t is equals to 0, so it's because in the function, when we substitute 0, we have 1 over 0 plus 1. So 1 over 0, say, it's undefined. So that 1 you're talking about, you can't add it to something that's undefined. So that's what I'm saying. So
the first part is undefined. We agree.
yes, sir.
The first part is undefined. Therefore, we cannot add the undefined. We cannot add 1 to the undefined part.
Correct.
Yes, sir.
Abdul, I'm quiet because I don't know whether others see it the way we are seeing it. That is why I'm quiet. That is why I'm quiet.
All right. But you must come it, because when there's that long silence, it's as if, as unsure as we are, it's as if we are wrong, you understand? So we even get more confused or even thrown off. So at least if you feel like no one is coming onto the platform, then you can come in and rescue us to say, yes, guys, I agree with this, or no, guys, I think you are wrong. This is how it's supposed to be done.
Hello, sir. Oh,
yes, Tando.
Yeah, this topic, but I heard what Spusiso is saying, because he's saying 1 over t plus 1 is discontinuous at t is equal to 0 with an infinity like discontinuity. So that means there are other values now. The function is continuous for all other non-zero values. The way how I heard it. So is it correct if I say the function is continuous for all other non-zero values of t?
Yes, it is continuous.
Yes. Now Abdul, you see now. You see why I keep quiet. Yes. Yes.
Like on number 4, can you include
Mm.
0? Can you include it in the solution?
Now, if you include it, Sibusiso, please help Lerato on this one.
Is like overall the whole equation.
Okay, Lerato. Let's write the answer like this. The function of g of t is infinitely discontinuous at t is equal to 0. And for any other value of t aside from 0, the function is continuous. So we don't include 0.
So +1, we leave it.
Okay, the +1 is part of the function, Lerato. You can, okay, tell me, 1 over 0 plus 1 is how much?
1. Ah,
How?
I don't know.
You
No,
can't
How,
add
Lerato?
that because
1 over
you
0
don't know
plus
1 over 0. You can't add something.
Yeah, I understand that. But like,
Lerato.
not- are you sure it's not 1?
it's an
Mm-mm.
error, Rato. So 1 plus an error is an error. Anything that you add to an error is an error.
Okay, it's fine then.
Yeah.
I
Okay.
said I understand,
Yes.
but about the others you are talking about, yeah.
You say you understand about those others, other values.
Yeah, now I understand. Yeah. When you said that you don't see,
Yeah. You know, as a mathematician, Sibusiso, ne? As I said at the beginning of these workshops, as a way of helping you, in summary, if you can just summarize maths is about patterns, and then you can determine or you can see a pattern if you only look at things from one angle. I don't know whether you get me. No.
We
Dando?
get you. We get you.
Hi, sir. Can I say something?
Yes, who's talking?
It's Princess.
Yes, Princess, how are you?
I'm well, thanks. How are you, sir?
Good.
I'm good, thanks. The way I looked at it was that our function is going to be continuous at all points of t, because if we take 1 over t and add it to 1, then we've got t over t. So plugging in 0, the limit as x approaches 0, then it becomes 0 over 0.
Princess, which question are you looking at? Which one are you referring to? We are on number 4. Are you talking about number 4?
Yes, I'm talking about number 4.
Okay. Let's say for me, you have what is these words? They usually say you add the wax to the spanner. You added the wax to the spanner. I'm confused now. Okay, what did you say? What are you saying, my sister?
I'm saying 1 over t plus 1 over 1 is equals to t over t.
1 over t plus 1 over 1 is equals to?
T over t.
One over t plus 1 over 1 is equals to t over t.
Yes.
I disagree.
Yeah, it's 1 plus t over t.
Princess,
Yes.
I disagree. Did you hear what Tando said?
Please repeat, Tando.
I said it will be 1 plus t over t. So it's still the same. It will be 1 over t plus 1. So that's why we were excluding 0. Because if you say t over t, I understand, but you made a mistake in addition there. When we add, yeah.
So it's 1 plus t over t.
Yeah, I think so. Because if you are doing like that, yeah, it will be 1 plus t over t. If you are adding those two.
Yes.
Okay.
That's why I'm saying I disagree with you.
Okay. And then if we've got 1 plus t over t, then t over t at 0 is 0.
T over?
T over t at 0 is 0. T over t at 0 is 1. So it's continuous everywhere.
0 over 0. That's 0 over 0.
Yes.
That doesn't make sense. If it is 0 over 1, yes, it's 0. But 0 over 0 doesn't make sense.
Okay,
What is 0 over 0? What is 0 over 0 according to you, Princess?
It's 1.
No, 0 over 1 is 1.
Okay.
0 over 0, no. I've never heard of that.
So what is t over t?
T over t is 1.
At 0?
Please don't confuse me.
At 0.
We can't have 0 over 0. 0 over 0 is nothing. And again, let me not say it's nothing, because when you say nothing, you are referring to 0. 0 over 1 is nothing, is 0.
Okay.
I disagree with you.
Okay.
You and I, let's agree to disagree on that one.
Yes.
Yes. Thank you. Now, are you okay, Princess?
Okay, sir.
Thank you. Now, let's continue. Let me take this opportunity to thank you all for having attempted this homework. Now, let's continue. Where are we continuing from? We are continuing from here.
5.
Sorry?
5.
Those are the only questions that I requested you to look at. If there are others, then those ones you can do them during your spare time. Okay. Is that okay, Lerato?
I just saw the answer. It's 5. That's what I wanted to know.
Oh, okay. I didn't even look at that. Taking into account the time that we spent just only on these ones. I'll tell you where it should be. Oh, it's not here. Oh, okay. Okay. Now, let me say, before I go where I want to go. Thank you for managing to go through that first part of the syllabus. That concluded the first part. We are now moving on to the other part of the syllabus, which is going to talk about the derivative. Remember, we agreed that after that section, the next section talks about the derivative. Eh? That's where we are
Yes.
going. That's where we are going. We'll be there, don't worry. We are almost there. Okay. Sorry. Now, we are going to spend the next few workshops talking about the derivatives. Now, let's go here. Yeah, I'm interested in starting from, show you where my interest is. I'll be there soon. Okay. May we please start by looking at derivative function. Yeah. Yes. Yes. It says, let's look at this definition. Derivative function, it says, let f be a function. The derivative function denoted by f prime. Do you see that prime? That symbolizes the
Yes.
derivative.
Yes.
Correct me if what I'm saying doesn't make sense. Please do say so. You dealt with derivative in metric.
Yes, sir.
Thank you.
Yes.
So it's just a continuation. Let f be a function. The derivative function denoted by f prime is the function whose domain consists of those values of x such that the following limit exists. F prime of x is equals to the limit of f, and even in metric it was defined like this. I mean in metric or grade 12 it was defined like this. The limit of f into x plus h minus f of x all over h as h tends to 0. We are saying a function f of x is said to be differentiable at a if f prime of a exists, meaning when you take the derivative of f and substitute a, that exists. More generally, a function is said to be differentiable on S if it is differentiable at every point in an open set S, and a differentiable function is one in which the derivative f prime of x, I'm not going to be saying I'm not going to be saying f prime of x. I'll just be saying the derivative from now going forward, in which the derivative of f of x exists on its domain. Notations. Some of you will, or some of you have already made a decision of whether they are going to follow applied maths or pure maths. In applied maths, this definition, you see this one that I've highlighted. Okay, let me just say this one, dy dx. You see this one? The first one is f prime of x, dy dx. This is one is mainly what we use in applied maths. Whether you use this first notation, second notation, third, or fourth, we're just referring to one and the same thing. We are just saying we are differentiating with respect dy by dx. We are just saying we are differentiating with respect to x. Thank you. Okay. At this point in time, this is what I need to share with you. Then I'll be happy. This is not the first time that you are seeing this. You saw this from Metric. Please. This is what we are continuing to talk about, you and I. This is one of the tools that you are carrying from Metric. Okay. I don't know whether this, okay. Let me skip this one to avoid confusing others. Maybe this one will make sense. It is all coming from this formula, okay? We are going to use this formula in the next few examples and exercises. Even in here, but let me skip this one to avoid confusing you. I think it's straightforward here. We agree that this one, please, if you didn't write it down, please write it down somewhere. Princess, did you write this down? This down somewhere?
Yes.
Okay. Tando, did you? Lerato, did you? Theo, did you?
Yes, sir.
Yes, sir. Yes, sir.
Mbongiseni, did you?
Yes.
Zimbongiseni still here? Left. Pumuzo, Alvin.
Yes, sir.
Sbusizo. Okay. Where should I go? Now let's come here to this example. Having written that down, what we are just doing in example 2.1.2, they are saying find the derivative of a quadratic function. Find the derivative of the function f of x, which is equals to x squared minus 2x. What is it that we need to do? We need to write f of x, which is equals to x squared minus 2x, in that form that I asked you to write down. Okay. When we do that, we know that the first term, we've got f into x plus h minus f of x all over h. So we know that the first one is x plus h. It will have to be squared. Minus 2 into x plus h. Close bracket, open bracket, and then the last one is the f of x. F of x, in this case, which is x squared minus 2x, all over h. We just put, substitute, and simplify. Look at this part. Focus on this part. Don't focus on the right-hand side. Focus on the left-hand side. In terms of the substitution. Are you still with me?
Yes, sir.
Okay, thank you. If you are still with me. Then after substitution, after substitution and after substituting and simplifying, at the end we end up having 2x minus 2. Tando, do you agree with that?
Yes, sir, I agree with. Yes, especially when you use a simpler one.
Yes. Anyone who disagrees? No disagreement. Okay, thank you. Now, if there is no disagreement, please find the derivative of f of x, which is equals to x squared.
Sir,
Hello, Lorado.
it's 2x.
Sorry?
2x.
Are you saying the answer is 2x?
Yes.
How, brother?
So, sir, first things first, you do that x plus h squared, and then you get x squared plus 2xh plus h squared minus x squared, and then x squared cancels the other x squared, and you have 2xh plus h squared, and then you derive, and then you have h at the outside as 2x plus h, and then you divide the h with the h, and then you're left with 2x plus h, but h is approaching 0, therefore you're only left with 2x.
I still disagree.
How come, sir?
Please ask anyone.
Guys, do you disagree?
Please talk to them. I disagree with what you just said. I'm sticking by 2x minus 2. So now that's why I'm requesting you. I'm stopping at this point in time. I'm requesting you to talk to them.
Oh, sir, you are
Yes.
doing f of x is equal to x squared.
Before we
Oh,
get to this one, you and I, we
one
need to
apart.
agree on the previous one first.
Oh, okay. The previous one, the answer is 2x minus 2. I agree.
Hey, Larato, please take care of this heart of mine. I think you are being reckless with this heart of mine. Larato, my brother.
Yes, I see. I thought you said you're doing the one for x squared, and I was like,
Okay.
oh.
Okay, hang on. Please, let's all work on f of x equals to x squared. And then when you are done, you just mention your name, then we compare answers. Okay.
Usizo is the answer.
Rato.
Tando.
Okay.
Busa.
Leratos, Vuzizo, Tando. Who else?
Princess.
Magwena. Before Magwena, someone was talking. Who's that?
It's Princess. Oh,
Princess and who? And Levo?
yes.
Okay. Levo, how are you?
I'm good, sir. How are you?
I'm good. Come on, go class again. When is it? Who else? Vincent. We have Vincent. Sorry?
I'm done.
Vincent, are you sure you are done?
Yes, sir.
Okay, thank you. Now, Let me start with you. Where should I go? Okay, Tando. Tando,
Hello, sir.
please help me here. I don't want to move from this page, ne, where I am. Ne?
Yes.
In this workshop, we have got yourself, Lerato, Sbusiso, Makwina, Princess, Lebo, Vincent. Who else?
Pumuto. Who is Pumuto?
Is Pumuzo not Vincent?
Okay, it's Vincent, yeah.
Yes. Who
Yes.
else? Who else?
Alvin.
Alvin. Yeah. Vincent, you will tell us your answer. After that, you will be followed by Alvin. Vincent, what did you get, brother?
I got 2x.
You got 2x.
Yes, sir.
Please talk to them.
Sorry?
Please talk to them.
Someone just explained not long ago this how we get the 2x. Do you want me to repeat it?
I don't agree with that 2x. So I'm requesting your explanation of how you arrived at that 2x. That 2x, in fact, is not what we're looking for. That's why I'm asking you to explain to us how you arrived at the 2x.
Okay. I've substituted. I used the formula x plus h minus fx over h, the limit when h approaches 0. And then when I substitute x plus h squared minus x squared over h, then I got x squared plus 2xh plus h squared minus x squared over h. Then I cancel x squared minus x squared. I was left with 2xh plus h squared over h. I simplified the h, was left with h into 2x plus h, and then the h cancel each other. I was left with lim when h approaches 0 is equal to 2x plus h. And then I substituted h with 0. That's how I was left with 2x.
Please talk to them. Ask them whether they agree with you or not.
Do you agree, guys?
Oh, okay, whoa. In fact, the person that you need to talk to now is Alvin. If there is agreement, if there is a disagreement between the two of you, then the two of you will have to talk to the rest of us.
Alvis, do you agree?
I agree, Vincent.
Okay.
Does he agree or disagree with you, my brother?
He agrees with me.
He agrees.
Yes.
Now the two of you talk to the rest of us. You at least talk to us. So now that's why we are requesting you to talk to us in terms of what you are saying is an answer.
Okay, guys, do you all agree with us?
Yes, we agree.
Yes, we do.
We do.
Thank you. Now, Alvin, the next exercise, I'm going to request you to be the first one to give us an answer, followed by Vincent. Okay?
Yes, sir.
Thank you. I don't know what you are doing. I'm being honest with you. I don't even know the answer. So this is what we are all agreeing on as an answer.
Yes, sir.
Thank you. Now, Alvin, you are number one here. Do you see this?
Yes,
Exercise 2.1.1.
I see it, sir.
Please find the derivative of f of x, which is equals to the square root of 2x plus 3. You will be the first one to give us an answer, then followed by your brother, Vincent. And then I'll be your third brother to give the others our answer. Okay, do we agree on that one?
I agree, sir.
Thank you.
Yes, sir.
Alvin?
Yes, sir.
Yes. Mhm. What did you get?
I got 3 all over 2x, the root of 2x plus 3 plus the root of 3. I think that's wrong.
Whoa. Slowly. You got 3 all
3
over
2x plus the root of 2x plus 3 plus the root of 3.
plus the root of 3.
Yes, sir. I think it's wrong.
You said you got 3 all over the root of 2x plus 3 plus the root of 3.
Yes, sir.
Thank you.
Yes,
Level, are you done, my sister?
yes, sir.
You will follow after Lucy, so I'll write your name here, Level. Now we are going. My sister, no. Now we are visiting one of the family members, Vincent. Vincent, what can we eat in your house tonight? What is the answer?
I'm almost done, sir.
Yes, we need that answer. Yes. Please share with us your answer.
Sorry, sir. This is Alvin speaking.
Yes, Alvin.
I'd like to change my answer
To which one?
to 1.
Tell me what to write. Tell me
Sorry?
what to write.
1.
Tell me what to write.
Okay, I got 1 all over 2x, the root of 2x plus 3 plus the root of 3.
Plus the root of 3.
Yes, sir.
That's the final answer.
That's my answer.
Okay, thank you. Vincent? Vincent?
Yes, sir.
Yes. Answer?
Yes. Answer. For me, it's still complicated. There's a lot of calculation that I'm still doing, so it's gonna take some time, sir. So I think can go ahead with the others, sir.
But I can't go ahead with the others. You said to me you need a few seconds. You needed 5 minutes. I gave the 5 minutes. 2 seconds ago, you said to me you needed 2 seconds. I gave you the 2 seconds.
Yeah, I'm afraid I don't want to make mistake by calculating fast. I'm gonna miss something.
Okay, Alvin changed his answer from 3 all over the root of 2x plus 3 plus the square root of 3 to 1 all over the square root of 2x plus 3 plus the root of 3. That's Alvin's answer. Now I'm going to Lerato. Lerato, what did you get, brother?
1 over root x.
1 over the root of x.
Yes.
Only.
Only.
Okay, thank you. Now I'm going to Sbusiso. What did you get, brother?
1 all over the root of 2x plus 3.
Thank you. Level.
Yes, sir.
Yes.
I got 1 over the root of 2x plus 3.
Thank you, Lebo. Tando.
By the way, sir, I'm also done. Sorry about that.
Hello, sir. I got one.
Theo, you'll follow after Tando.
Sure.
Yes, Tando, what did you get?
1 over square root of 2x plus 3.
Thank you, Tando. My brother, Theo, what did you get?
So I got, my answer is 2 over 2 times 2 over 2 times square root of 2x plus 3.
2 over 2, the square root of?
It's 2 over 2 times the square root of 2x plus 3.
2 times the square root of 2x plus 3.
Yes, sir.
Thank you, brother.
Sure.
Say,
Uh,
can I mention something?
Yes, Busiso.
Can Theo simplify his answer? 2 over 2 is 1, sir, so he doesn't get lost or complicated. 2 over 2 is 1, which is 1 all over the square root of 2x plus 3, sir.
Do you agree, Theo?
Yeah, definitely.
Thank you, Busiso.
Thanks, Busiso. Thank you very much.
Now,
Welcome.
Now, Alvin has got 1 all over the square root of 2x plus 3 plus the square root of 3. Alvin, please explain to us how you got that answer.
Okay, so I started with.
Hang on, Alvin. May we please all listen attentively to what Alvin is saying? Please go ahead, my brother.
Okay, so sir, I started with finding f of x plus h, which is 2, which is the square root of 2 into x plus h plus 3. I'm still with them?
We are
Am I still?
listening.
Okay. So then now I proceed to finding f prime x using the formula, which is limit as h tends to 0 of f of x plus h minus f of x all over h. Then I substituted my values. I substituted the function rather, which I found, which was 2, which is square root of 2x, 2 into x plus h plus 3, substitute minus the square root of 2x minus 3 all over h. Then I tried to rationalize I tried to remove the root actually by multiplying with the square root of 2x 2 into x plus h plus 3 plus the square root of 2x plus 3. That's what I multiplied what I already have. Am I still with everyone?
Yes, we're still here.
And I think I made a mess in that step. I think I made a mess.
How? Why?
It was that extra 3. It was the extra square root of 3.
I'm still trying to understand how you got at the final answer.
Okay.
Mm,
So on the top, I've got
mm. 1.
the I've got the square root of, okay, sorry, let me just repeat this. I changed the h, the denominator h, to 1 over h because now I've got like a bit of a fraction here. So it'll be this, the fraction that I do have is the square root of 2x plus h, 2 to x plus h plus 3 minus 2x plus 3. My denominator for that one is 2, the square root of 2x plus h plus 3 plus the square root of 2x plus 3. So then I went to work with the numerator, canceling out the 2 x's. I'll be left with 2h. The 3's also cancel out. So I'm left with 2h all over square root of 2x plus h plus 3 plus the square root of 2x plus 3. Am I still with you?
Yes, we're still listening.
We're with you, Theo. I mean, Alvin, we're with you. Don't worry. Alvin,
Yes, sir.
we are with you.
We're still listening. You are at 2h over something. We are listening.
Please continue.
Then from there, I just decided to apply the limit, which was h tends to 0. Actually, before that, I canceled out the h because of the cross multiplication, which left me with 2. My numerator would be, actually my numerator actually would be 2.
Numerator will be 2, and then
And I still have that fraction of the square root of 2x plus h plus 3 plus 2x plus 3. Then from there, I just applied the limit.
Then how? And then what did you get? Brother, by allowing everybody this opportunity to share with us how they arrive at the answer. That is the only way that we can be able to learn and help out each other. We are not trying to show how smart others are than others. That is not the purpose. So feel free.
My apologies, sir. It's just that towards the end, I just skipped some steps.
You skipped some steps. Alvin, you are confusing me. Which steps did you skip? And then after skipping those steps, then what did you then have?
I ended up with what my final answer would be, which is 2x, 1 over 2 square root of 2x plus 3 plus the root of 3.
Okay. Let me ask you this question. According to you, my brother, do you think there is something that you were not supposed to make that you did make in the process?
I think there was an issue.
Sorry?
I think there was something I did that wasn't really supposed to do.
I'm not saying there is you made something that you were not supposed to make. That is not what I'm saying. I'm not even ruling out on this answer that you shared with us, but I just need us to make sure that we have the very same answer. That is the whole idea. Thank you for that explanation, Alvin. Now, Vincent is out. Now, in this order, let me bring in Lerato. Alvin, please pay attention, my brother. Not only you, everybody, including Vincent. Lerato?
Okay, so the first thing I did, I used the formula and I got square root of 2x plus 2h plus 3 minus in bracket square root of 2x plus 3 all over h. And then I multiplied the formula by square root of 2x plus 2h plus 3 plus, like positive in the middle of the two square roots, positive plus, and then in its bracket, square root of 2x plus 3, the denominator and the numerator. And then I multiplied that into the formula. And then I got 2x plus 2h plus 3 minus, in brackets, 2x plus 3. My denominator was h, in brackets, square root of 2x plus 2h plus 3, in between plus, and then the other square root of 2x plus 3. And then I worked out the top to remove the bracket where 2x turned into negative 2x, positive 3 turned into negative 3. And then my numerator, I was left with 2h. My denominator is still the same, h times square root of 2x plus 2h plus 3. In between the two sets, plus square root of 2x plus 3. And then 2h cancelled out the denominator of h. And then I was left with 2 as the numerator. The denominator was square root of 2x plus 2h plus 3 plus square root of 2x plus 3. And then h, as it approaches 0, it's 0. It cancelled out the 2h. It became a 0. And I was left with 2 all over square root of x plus 3 plus 2. I was left with 2 all over square root of 2x plus 3 plus square root of 2x plus 3. From there, I think I used that's where the mistake happened. At that point, I don't know how to add sets. So I just said, since when you're deriving or something like that, the constants are not derivable. I cancelled out 2 and 3, and I was left with 2 all over square root of root x plus root x. And then I know that root x plus root x is equal to 2 all over 2 root x. And then I cancelled out the 2, and I was left with 1 all over root x. Yeah, that's how I did it.
Thank you, brother. Please talk to them.
Here's my question. Can I ask Lerato a question?
Yes, brother.
Okay, Lerato, what's b plus b?
2p.
Okay, so the root of 2x plus 3 plus the root of 2x plus 3, what is it?
Root x plus 3.
Bingo.
Oh, I shouldn't have cancelled the 2 and the 3. I should have kept it that way. We can see now.
Answer the question, Legato. I can't see if you see. Answer the question. What is the root of 2x plus 3 plus the root of 2x plus 3?
It's 2 root 2x plus 3.
Yes.
Yeah, done. Then your problems are solved forever. No.
Okay.
Yeah.
Yeah, and another thing, the problem is not solved forever. This guy, after that step whereby he was supposed to add those roots, he was deriving.
I derived before to cancel the 2 and the 3 because I thought like 2x plus 3 plus root 2x plus 3 is too big. So I canceled 2 and 3 and I was left with root x plus root x. And then I got 2 root x from that one. And then
Yeah.
Why do you derive inside deriving?
Because I thought the rules were different when you are adding 2x plus 3 and when you are adding root x. I tried
Yeah, Mara, you are not supposed to derive by using that formula. You are now already you derive automatically. So you are not supposed to derive anywhere. Oh. Yeah, guys. I think we are done. Yeah, talk to us, Larato.
Yes, sir.
Yes, Level. Please talk to Larato. Level, please talk to Larato.
Larato.
Yes.
Are you okay, man? Okay, yeah, I know. Everything is all right. Now you understand what's going on.
I'm okay, my mom.
All right.
And to you too, Level and Larato. Come on, Yoko class, ne? Level, come on, Yoko class. Larato, come on, Yoko class, ne?
Yes, sir.
Thank you. We agree, ne, Larato?
Yes, we agree, sir.
Thank you. That is what we were supposed to get. We don't know. Okay, before I continue, I need your guidance here. Please help me out. Please motivate me. I'm demotivated. Level.
Yes, sir.
Please motivate me. I'm demotivated.
Okay.
What happened during this workshop really got me demotivated. I'm referring to an incident, that incident of Vincent.
What happened?
Please help me out. All of you. How do we deal with this kind of a situation?
I think for the sake of procedure and movement sake, like you said, this is a space for everyone. We are all here to learn. We are not testing who's smart and who's whatnot. So if someone doesn't utilize the platform, say there's no way we could punish or reprimand. So it's just a matter of, I think we should let them go for the sake of all of us to be able to move. But it's going to be said if that person doesn't really understand and was given the opportunity to come onto the platform to be helped, but they didn't take that opportunity. But as for punishment and whatnot, say, I would say I don't think there is a solution to it, but I'll hear what other colleagues say. I think with the Vincent issue, it's just a matter of If you are offered the opportunity and you don't utilize it, there's nothing we can do. We'll just move on with the others.
If I may ask, what happened, Vincent?
Vincent was supposed to be giving an answer there, like, so he didn't give that answer. It's
And then
I'm not.
But Vincent is here, guys. Are you
Vincent
preparing to
is here.
Bumbuto? He's here.
Where is Vincent? Vincent.
I'm here.
Come in, Vincent. Talk. Yeah. Talk to say. Can you try and motivate here, Vincent?
No, I was just too slow to calculate, and I didn't want to waste your guys' time. So I was trying, because I was slow on calculating. But when I calculate, I got 1 over the root of 2x plus 3, which was wrong.
1 over?
The root of 2x plus 3.
That is correct. That's the answer.
correct.
Oh, okay.
So can you see where you are supposed to be coming in, Vincent, in terms of what Say is saying? You find that, let's say your answer was wrong, and you could have stuck with that answer and you could have just continued like that. So I would also kindly ask as a colleague to say that, please come onto the platform. Whether you are right, whether you are wrong, or you are not sure, just give what you have. And then remember, we will all come together and discuss the answer, and then we'll all go for the right one. So don't ever feel shy or feel like you are somehow, when you don't give the answer correctly or something like that.
Yeah.
Thank you all. We are all here to learn.
Sir,
Yes.
I have a question to ask the colleagues. If during, like for this module, I'm not sure, do the colleagues know how much you should get in the assignment so that you can be able to write the exam or not? Because it's bad, man. Because like there's an assignment on driving only, and the due date is, and
you're breaking
is that if you just submit, remember there are some assignments where they just say submit assignment 1. They don't say get 50 out of 50 for you to be accepted. They say just submit. So you find that just by the mere act of submitting, you've qualified already. It's not a matter of you got 20 out of 100 or whatever. They look at maybe if you just met whatever those requirements. So as long as you got the marks, they won't, I don't know that much, but they won't disqualify. As long as there's something you've done, the final exam is the one that has the final say. So I don't think you will be discouraged in any way.
No, I was thinking like I would not qualify for the exam because we had an assignment on driving. You remember, Ker? And I can see from today's session that I corner. I do look.
Lerato, this one's in low. My brother.
That one, say.
My brother. This one's in low. There is no other way.
Yes.
By hook or crook.
Because like ish. But this,
as long as I'm still here with you, this is the platform where we have to solve all the challenges. We must. We can't continue like that, Lerato. It is still early. All the problems that we are currently facing, we need to deal with them.
yes, sir.
That's why I tell you that we don't have to wait for tomorrow. The time is now. You know, when I switch off from each and every workshop, I look back. When we start at 5, when we end either at 7 or 7:30 or even 8, I look back at what we did. I look back at the people that are engaged with in the workshop. Those people that did not participate, the people who participated. It doesn't mean that I just switch off my laptop and say, okay, it is done. That's not how I operate. I'm someone who needs to move along with you every step of the way. That's why I tell you that I don't want to have nightmares. I need to make sure that we are all on the same page. At the end of the year, Lerado,
Yes, sir.
I don't want to be with you in this workshop next year, in this
Okay.
module. Not only you, all of you. What I'm just saying, I'm not trying to discourage you. I'm trying to encourage you to work harder so that at the end of the year, you all make it through. Get me clearly on that one, please.
Yes.
Our
sir.
time is now to deal with what we are facing for us to can be able to go through this module. It's not next month, it's not next week, it's now. That's why I'm worried when people come to the workshop and do not participate. Please, people, I'm still begging you, let's work together. At the end, it is not about me, or it is not about you, Lebu, or Abdul, or Sbusiso. It's about us collectively as a unit making it through at the end of the year. Are we together, people? Brothers and sisters?
Yes.
Are we together,
together.
family?
Yes, sir.
We are
Yes,
together.
We are
together,
together,
sir.
sir. And
Please.
Spusiso is gonna motivate you with the right answer right now. Spusiso, motivate sir for us, man. Please motivate him.
Please,
Sir.
please, people, please. I'm begging you. Let's work together. At the end, you know, at the end, when you will be climbing that stage, we'll be climbing it together. That is my wish. I don't need us to be climbing that stage, leaving others outside the wall. No. We should go into that wall, all of us. Please. Please. Can I request you to take this one as a homework? Do you see example 2.1.3?
Yes, we see it, sir.
Consider f of x, 3 over x. Find the derivative of x using the definition of a derivative as a limit. Please take this one as a homework. We'll talk about it tomorrow.
Sir, kopansa Spusiso, sir.
Abdul, please come back again. You say I should
Can we have
answer?
Spusiso's answer? Yes, can we have Spusiso's answer?
On which part?
Everything,
Yes.
my man. Motivate
Everything.
from the top, from everything, from the top.
From
Don't
the
miss
top.
anything.
Okay. Okay, sir. I'll start here. People I shall start with the colleagues. The trick in being able to do not every, because there are some hard questions. The trick in mathematics is mastering the basics of algebra, meaning being able to factorize, the laws of exponents, knowing the rules behind the square roots. Then if you know those, then the other things will be simple. So if we can master those things, then apply the laws we are learning from the workshop and the textbooks, then I believe we can make Sir happy. And Sam, don't lose hope yet. I think we still have a couple of months, and it takes 1 month to master maths if you put the time and dedication and place more practice. And say, I have a request. Can you send question papers for us to practice more? I think that will also help. And you are doing a great job, sir. You're doing a great job. Don't be disappointed. The fault is not you, but the person who's not asking for help.
I
Thank
agree
you.
with Usisi. Awusuka amadoda izinto. Ama-top dog. I agree.
Can we agree that we'll see each other tomorrow?